All right, class, today we're going to cover chapter 7, which is about roots, radicals, and radical functions. The first thing I want us to discuss is simplifying radical expressions, and then in the next video we're going to talk about graphing radical functions. So, in previous chapters we have studied exponents, right? Exponents can be used to square a number. So if I have 3 squared, it is equal to 9. If I have 2 cubed, it is equal to 8. Now we're going to study square roots and cube roots, okay, which take us from the root of a number back to the number itself. So if I have the square root of 9, it's 3. Essentially, square roots undo squares. So let's say I want to take the nth root of a, and that's going to be b. That means if I take b to the nth power, we would get a. Let's go through some examples to make sure we understood what I just said. So let's say we're taking the second root of 36. That's the square root of 36. Typically, we wouldn't put the 2 there, okay? So if I have the square root of 36 is 6, that means 6 squared is 36. If I take the cube root of 27, which is 3, that means 3 cubed is 27. If I take the cube root of negative 27, that's going to be a negative 3 because negative 3 cubed is negative 27. Okay? So let's go ahead and solve the following. So let's say I want to take the square root of 64. There should be a button in your calculators that can help you do with square roots, or you could do this by creating a factor tree. 64 is a perfect square, which is really nice, and it is 8. So we would know that 8 squared equals 64. If I take the cube root of 64, the cube root of 64 is going to be 4. So if I take 4 cubed, that gives me 64. I'm going to take the cube root of 125, okay? And I'm going to work this one out by making a factor tree. So I have 125. That factors into 5 times 25, which factors into 5. So if I have 5 cubed is 125, because I've got 1, 2, 3, then the cube root of 125 is going to be 5. Okay, let's take the fourth root of 16, okay? 16 factors into a 4 and a 4, which factors into a 2 and a 2, and a 2 and a 2. So 16 is 2 to the fourth, so the fourth root of 16 is going to be 2. Now, what if I'm taking the cube root of a fraction, okay? Or the square root for that matter. I'm going to take the cube root of the numerator over the cube root of the denominator. The cube root of 8 is going to be 2. The cube root of 27 is going to be 3. And that's because if I made a factor tree for 8, I would get 4 times 2, which is 2 cubed. And if I have a factor tree for 27, that's going to give me 9 times 3, which is 3 times 3, so 3 cubed. All right. Now, let's look at some bigger roots, okay, and what's going to happen when negative numbers get involved. So, if n, which is the degree of our radical, is positive or 0, then we want to find the principal nth root of a. Okay, if we put a negative outside our radical, we call that the negative root of a. And why do I even have to make this clarification? We have to make this clarification for one specific reason, and that is the fact that if I want to get 9, I could take 3 times 3, or I could take negative 3 times negative 3. Both would give me 9. So if I was asking for the square root of 9, when I do this, I'm asking for the principal square root. If I put a negative outside, if I'm looking for the negative square root of a, I would do negative square root of 9. We simplify our square root of 9, and the negative comes with us, so it's negative 3. Let's work this through with let's take a look at the second case then. If n is even and a is a negative number, then our answer is not a real number. I cannot take the square root of negative 9. I cannot take the cube root of negative 8. Okay, these answers would be a complex number, which we're going to cover at the very end of this chapter. And if our nth degree is odd, then there's exactly one real root of a written in square root of a. I can take the cube root of negative 8. So I can't take the square root of negative 9 because n is even, our n is 2. But because n is odd, when I have the cube root of negative 8, I would get negative 2 cubed, because negative 2 times itself 3 times gets us back to negative 8. I can also take the cube root of positive 8. That would give me a positive 2. Okay, so if n is odd, then there's exactly one real nth root. So if I take the square root of 100, that's going to be 10, because 10 squared is 100. If I have a negative out front, the square root of 100, that gives me negative 10. Let's do a couple more examples. Let's say I want to find the fourth root of 81. Okay, this means I'm looking for the principal square root of a. The fourth root of 81 is going to be 3. If I didn't know that, I could factor 81. 81 is 9 times 9. 9 factors into 3 times 3. So 81 is 3 to the fourth power, because I have 1, 2, 3, 4 3's. Now, I'm going to take the negative fourth root of 81. That means I would have negative 3. Last, 4 square root of negative 81. This is even. This is when case 2 comes into play. This is even. What's under my radical is negative. This is a complex number. And at this time, we are unable to solve these, okay? All right, let's try this again. What if I take the cube root of negative 8? I already told you guys 2 slides ago that negative 8 is negative 2 cubed, so I have negative 2. The cube root of 8 is going to be a positive 2. And if I have the negative of the cube root of negative 8, that's like saying I have a negative 2, which is just going to be a positive 2, because 2 negatives make a positive. You can also think of the principal square root in terms of absolute value. Remember, these little bars mean absolute value? Absolute value is always positive, right? It measures our distance from the origin, which is 0, on a number line. So if I took the square root of 7 squared, my answer is going to be 7, right? Square roots cancel squares. If I take the square root of x squared, my answer is going to be x. But here I have negative 7. We want to make sure we're going to take the absolute value of negative 7. One way to see this is to simplify, right? So let's PEMDAS this. If I have the square root of negative 7 squared, that's going to be the square root of 49, which is just 7. Or we could have taken the absolute value of negative 7, which would also have given us 7. Either way, you would get the correct answer. Now, if n is an even positive integer, then the square root of n then the nth root of a to the n is going to be the absolute value. If n is odd, right, because then it is unique and only has one root, we're just going to have our value a. So here I have the square root, the sixth root of negative 3 to the 6. This is even, so I'm going to have the absolute value of negative 3, which is 3. Since I'm taking the fifth root of negative 4 to the 5th, that is an odd positive integer, so my answer is going to be negative 4. Just a, just what's under the radical. Okay, if I have negative fourth root of negative 9 to the 4th, this is going to give me a negative. This is even, so I'm taking the absolute value of negative 9. That gives me negative. The absolute value of negative 9 is a positive 9, so my answer is going to be negative 9. Let's try this again, and let's think about what we're doing. So when I'm taking a square root, in this case, I'm wondering, what would I have to multiply by itself twice to get m to the 4th? So what squared equals m to the 4th? Well, remember our exponent rules. When I am taking an exponent to another exponent, I multiply them. So this would be m squared squared is m to the 4th, because we would be multiplying these two exponents. So I get a negative m squared, right? 4 divided by 2 is 2. Keep that in mind. Now, if I have a to the 12th, and I'm looking for the cube root of that, I'm wondering what cubed is going to equal a to the 12th. So what times 3 is 12? 4. A to the 4th. 12 divided by 3 is 4. Let's take a look here. If I have x to the 12th, I'm wondering, what do I multiply by itself 4 times to get x to the 12th? 4 times what gives me 12? 3. So my answer here is x cubed. 12 divided by 4 is 3. 12 divided by 4 is